Okay, so here, risk and risk aversion. So let UW represent what we call a utility function. Okay, U is a function that converts dollars into pleasure, happiness, or utility. Okay, so it allows someone to make a difference between $15 and $75 in terms of whatever happiness the person can achieve with the different amounts of money. So U is a utility function. So we want this function to be increasing and concave. So increasing, so being richer is more fun than being less rich. Okay. So with WB larger than WA, U of WB, so the function produces more happiness with WB than with WA. Or we could say the slope of the function is always strictly positive. Giving, so if you're a student, okay, or if you're poor, okay, and you have difficulty making ends meet, and someone gives you $1,000, it will generate a greater boost in utility than if you go see the CEO of a big company paid many $1 million a year, and you give that person $1,000. Okay, so increasing the wealth of someone who's poor generates a greater boost in utility than increasing the wealth of someone who's already rich, which means the slope of the curve for small values of W is greater than the slope of the function with large values of W. So we say the function is concave. So in what follows, we want U to be a concave and strictly increasing utility function, and we will show graphically that concave utility means risk aversion. So here's our utility function. So wealth is at the bottom, U of W is on the vertical axis. So take WA, here's the happiness WA generates. Here's WB. And U of WB is the happiness that B produces. The function is strictly increasing. So more wealth translates into a higher value of utility. And the function is strictly concave. So at WA, the slope is steeper than at WB. Good? So consider again an investor facing two possibilities. So WA with probability PA and WB with probability PB is 1 minus PA. Expected wealth is PA times WA plus PB times WB. So the weighted average of WA and WB, the weights being the probability of each possibility. And the expected utility is the probability of each possibility times the utility of each possibility. In what follows, we will show that if U is strictly concave, then the utility of the expected wealth is strictly larger than the expected utility of wealth. And we will use this relationship to explain that someone with a concave utility function is willing to sacrifice some of his or her expected wealth in order to reduce the risk of the possibilities he or she is facing. Which means someone with a concave utility function is averse to risk. So here's our utility function again, and here we have drawn a straight line between U of WA and U of WB. The expected wealth is here. It's simply the average between each possibility. So it's not right at the center because the probabilities are not exactly 50-50. So if the probability of A was 50%, probability of B 50%, W bar would be right in the middle. If the probability of B occurring is larger than the probability of A occurring, then the expected wage will be closer to WB than WA, which is the case here. So here's the expected wealth placed here by assuming some probabilities that we have not defined yet. So we don't need to define them for this example. And the utility of the expected wealth is right here. And in what follows, we'll try to discover what is A. Okay, and we will discover that A is in fact expected utility. So we will show it rapidly. It's not part of the exam. It's only for like a better understanding. Let's complete the triangle. Okay, so here we have a triangle with a right angle. Okay, so here we have a 90-degree angle. So these triangles have like practical properties. So y2, what is it? U of WB minus A. Okay, we will use this equality later. Y1, what is it? A minus U of WA. Good. X1 is W bar minus WA, and X2 WB minus W bar. Okay. Now some trigonometry. So these two triangles here are proportional. Okay, so by just cutting the pieces of one right triangle and forming like smaller right triangles with the first larger triangle, gives us triangles that are proportional. Okay, so any triangle I could be forming here on the hypotenuse, I mean, would be they would all be proportional. Okay, what do we mean proportional? We mean that take one side. Okay, y1 here, that's the side of this triangle here, divided by x1. So the whatever the platform, the base, okay, of this triangle, and the ratio we obtain is the same as y2 over x2. Okay, so y1 over x1 is equal to y2 over x2. Now, if we rearrange this, so I could put all the y's on one side of the equation and all the x's on the other side of the equation. So this is what I do here. So I put the x's on the left-hand side of the equality and the y's on the right-hand side of the equality. So x2 over y1 is equal to y2 over y1. So we will use this relationship to find the value of A, to show that the value of A is equal to expected utility. So x2 over x1 is equal to y2 over y1. Good. Okay, now we make the demonstration. So we have shown that x2 is WB minus W bar, x1 is W bar minus WA. We rearrange this as a function of W bar, and we obtain W bar is equal to this. So this fraction here times WA plus this fraction here times WB. But we know that W bar is the expected wealth. So the expected wealth is PA times WA plus PB times WB. There's no other way, okay, to obtain W bar with a linear function using A and B. So this means that x2 over x1 plus x2 is PA, and x1 over x1 plus x2 is 1 minus PA. Now we have the ratio of y2 over y1, which was utility of B minus A, divided by A minus utility of A. But now we have shown in the previous figure that y2 over y1 is equal to x2 over x1. So x2 over x1 is equal to this fraction here. Which means that if we arrange this here, this equation here, we rearrange it, we obtain A is equal to x2 over x1 plus x2 u of A, plus x1 over x1 plus x2 u of B. But we have shown earlier that this term here is PA, and this term here is 1 minus PA, meaning that A is equal to expected utility. Good. So this means that if you have your expected wealth on the horizontal axis, you draw a straight line up to the utility function, okay? And at the same time, you draw a line from U of WA to U of WB. Well, the blue line will cross this dotted line here, right at the point where utility is expected utility. And now we've just shown that the utility of expected wealth is larger than the expected utility. So utility of expected wealth is higher than expected utility. Okay, the certainty equivalent. And this is where we will show that return is good, but risk is bad. The certainty equivalent is, take that person facing A or B and give that person WC such that she or he is indifferent between the two possibilities A and B with probabilities PA and PB, or WC. So WC is the certainty equivalent. Okay, it's a certainty, so there's no risk to WC. It's given to you, and it's equivalent to WA with probability PA and WB with probability 1 minus PA. How is it equivalent? It's equivalent in terms of expected utility. So the expected utility of C is U of C. Okay, there's no probability attached to WC. So WC is given with probability 100%. So we want WC to give the same level of utility as the expected utility felt by the individual when facing the two possibilities WA and WB. So with the concave utility function, WC is strictly smaller than W bar. Okay, why is it? So here we have W, the expected wealth. We have shown earlier that the expected wealth crosses the dotted line, starting from the expected wealth, crosses the blue line at the level equal to expected utility. And now we have just defined a certainty equivalent, okay, which is an amount of money you give with certainty to that person so that he is indifferent between the two possibilities A and B. And this is our certainty equivalent. With a strictly concave utility function, the certainty equivalent is smaller than the expected wealth. What does it mean? It means, take a person with a concave utility function. This person is willing to let go a fraction of her expected wealth in order to be given an amount of wealth which is slightly smaller, but that provides her with the same level of utility. Okay, so that person is willing to pay in terms of expected wealth in order to reduce the risk of the possibilities she is facing. So a person with a concave utility function does not like risk, is averse to risk. Okay, so this shows, okay, like very rapidly, that for when a person has a strictly increasing and strictly concave utility function, so that person likes return, so return is good, risk is bad.